Now in this lesson we're looking at what's known as the nth term of a sequence. Let's look at some examples. We're asked to find the formula for the nth term, and that's denoted by a u with a little n, subscript n. Now we need to find the connection between n and u, subscript n. So we look at the bottom numbers there, 3, 5, 7, 9 and 11. They are going up by 2. So we're going to say that un equals 2 times n. In other words, we're doubling the original number. We might need to adjust those. So if we double that, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So that's what we're getting after we double the numbers. 2 times 4 is 8. 2 times 5 is 10. That's what happens after we double the numbers. Let's look at the numbers we're getting. These are the numbers, though, we require, which in each case seem to be one more than what we're getting. So we need to add 1. So there's our rule. un equals 2n plus 1. Our second example. We're asked to find the nth term for the sequence. Okay, the sequence is 1, 5, 9, 13, 17, etc. Now what we'll do is we'll change that sequence into a table where we have the position n and the actual term which we denote un. Now the position. Okay, the position is simply where these numbers come. There's a first, second, third, fourth and fifth number there. So the position we have 1, 2, 3, 4, 5. Okay, first, second, third, fourth and fifth. Now the actual term, though, are the terms that's highlighted there. The 1, the 5, 9, 13 and 17. Now if we look at those numbers there, what is happening? What is happening in that sequence? It's going up by 4. So we say that un, that the term we're interested in, is 4 times n. Now let's multiply by 4 and see what we get. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So at the moment, this is what we're getting after timesing by 4, but these are the numbers we actually do want to eventually get. So to get that, we need to go back another 3. So we need to subtract 3 in each case. Now let's see whether that rule works with the next two numbers. When n is 4, 4 times 4 is 16. Then we subtract 3, and yes, we get 13. When n is 5, 4 times 5 is 20, and then we subtract 3, we do get 17. Excellent. So that rule does work. So that is in fact our nth term. Our third example, we need to find the nth term for this sequence, 2, 5, 10, 17 and 26. So very similar to the one above it, where we draw the table. We're talking about the position n and the actual term un. Now again, there are 5 numbers there, so they're holding the first 5 positions, 1, 2, 3, 4 and 5. And the actual terms are the ones that are highlighted. So the terms are 2, 5, 10, 17 and 26. Now we look at these particular numbers. Are they going up by any set pattern? Well, firstly it goes up by 3, then 5, then 7, then 9. Well, when that's the case, what we're going to try to do is square the numbers and see where that leads us. So we say un, the nth term, is n squared. So we're squaring the numbers. And then we'll see what we need to do. When we have 1 and square it, we get 1. When we have 2 and square that, we get 4. 3 squared is 9. So these are the numbers we're getting after we square them. We actually want the numbers there highlighted in green, which seem to be one more in each case. So if we try adding 1, let's see how that works. There's our rule we're going to use, n squared plus 1. So when n is 4, 4 squared is 16, and then if we add 1, yes, we get 17. When n is 5, 5 squared is 25, and then adding 1, we get 26. Excellent. So there is our nth term. So we say un equals n squared plus 1, where un is our nth term. Excellent. Example 4. Now the nth term of a sequence is given by this rule, un equals 2n minus 1. And we're asked initially to find the first 4 terms. Well, there's our rule, un equals 2n minus 1. Our first term is denoted by u1. In other words, u1 there, where we see the un, we've replaced the n with 1, being our first term. So the rule is 2n minus 1, we replace the n with 1. So it equals 2 times 1 minus 1. And 2 times 1, of course, is 2, subtract 1, and we get it equal to 1. Our second term, denoted by u2. So where we see n, we replace with 2. So it equals 2 times 2 minus 1. 2 2s are 4, take away 1, we get 3. Our third term, do you know what we might denote it as? u3, that's right. So there's our rule, 2n minus 1, but we're saying n equals 3. So it equals 2 times 3, then minus the 1. 2 3s are 6, take away 1 equals 5. Our fourth term, denoted by u4. So there's our rule, 2n minus 1, replace the n with 4. So equals 2 times 4 minus 1. 2 4s are 8, take away 1 equals 7. So they are our first 4 terms. There's u1, u2, u3, u4, and they end up being 1, 3, 5, and 7. So therefore we write that the first 4 terms are 1, 3, 5, and 7. Now part B of this question, we're asked to find the 50th term. Well, the 50th term is denoted by u50. And there's our rule, un equals 2n minus 1. Replace the n with 50. So it equals 2 times 50 minus 1. And 2 times 50 is 100. Take away 1 is 99. Therefore, we can say that our 50th term equals 99.